Hi everybody, here is a video on visual inspection for graphs in applied behavior analysis. So for this video, I have one objective for you guys, and that's to know how to analyze results via visual analysis of graphs. So our agenda for today, we're going to talk about the importance of analyzing data. We're going to talk about analyzing data in the baseline phase, and then how to compare the baseline phase data path to your intervention phase data path. And to do that, we look at the level, the trend and the slope, and the variability. All right, let's get started on looking at the importance of analyzing data. So when you guys collect data, you are going to take those repeated observations and graph them most typically on a line graph. We've talked about graphs previously. We've talked about how the most common graph that you guys will use in ABA is that line graph. Now, after you take data, you want to graph each data point immediately after data collection. So after your observation period, whether it be a class period or lunchtime, whatever it is, you want to go and graph those data. Now, I understand as teachers, you guys are crazy busy, you're switching classes, things like that. So if that's not possible, then make sure that you do graph each data point at the end of the day before you leave. So either one, I say graph the data point as quickly as possible. So either right after observation period or at the end of the day. We do that. We graph immediately or we graph as quickly as possible because we always want to have an updated graph. And if we have an updated graph, that lets us consistently analyze our data. And I have this picture here for you guys. It says, "Keep analyzing, my friends." So in ABA, we're always collecting data and we're always graphing it and analyzing it as we're running our baseline phase or as we're implementing our treatment or our intervention. And graphing immediately and having an updated graph allows us to consistently see the direction of the data path, which allows us to very quickly identify whether or not the behavior changes when the treatment is introduced. And it also helps us make decisions about continuing treatment. So if we can see, if we're graphing consistently and we can see that our data path is not going in the way that we want it to, so either we're implementing a treatment and our behavior is continuing to increase and it shouldn't be, then that allows us to immediately see that trend and allows us to change something with our intervention or alter something. So that's really important. We're always analyzing. You have an ethical obligation to provide your learner with a treatment that's effective. So graphing immediately and looking at those data paths ensures that you uphold that obligation. Now, when we analyze our data, we're gonna be looking at the behavior under different conditions. Typically, you look at the behavior under a baseline condition and the intervention condition, and you're going to compare those two. You're going to compare the data path of those two conditions. So let's talk about baseline first. With baseline, this is that initial period of observation where you're determining the natural frequency of the target behavior. So this is, how frequent or how long is a behavior occurring under natural contingencies in the natural environment. So if we look at these data right here, on the y-axis we have the 2-digit multiplication problems, and on the x-axis we have sessions. You can tell it's baseline data because you should have a condition label up here, and then you can look at your data path in the baseline phase. Now there's a couple of different ways that the data path could go. It could be level, which is great. It could be increasing or ascending, and it could be decreasing or descending. So those are kind of our three directions. It could be level, increasing, or decreasing. Now, you want to run your data path until the data are stable. And what we mean by that is if you take the mean of the data, you don't want a lot of variability. So you don't want the data paths to go very far from the mean. The closer the data paths are to the mean, the more stable your data are. And also you can look at, can you draw a good line through your data? If you can, then your data are pretty stable. So we look at this graph right here with the level. We can see a pretty clear line. So that means that our data are pretty stable right here and that our data paths don't venture very far from the mean. So there's not a lot of variability. We can look at our ascending graph right here. We can say that we can draw a pretty clear line through this. So there's not a lot of variability, and our data here are pretty stable. Same with the descending. You can draw a pretty good line, and that means that your data are pretty stable. But look right here. We can't draw a very good line here. There's a lot of variability. Our data points are venturing or separated really far from our mean. So we would say that this is variable, and we have lots of variability in these data. When you have lots of variability or your data paths are variable, then you want to continue the baseline until you do have a stable baseline data path. And typically they suggest you have at least 3 to 5 data points that are stable before you implement your intervention. So continue your baseline until it's stable, then you can implement your intervention. If you have a lot of variability, keep going with your baseline phase until your data are stable, and then implement your intervention. Okay, and the purpose of the baseline phase is to describe and predict. So if we have a stable baseline, we can describe those data. You know, we can say that our data are venturing among I don't know, we don't have a y-axis here, but on average about 3 times per observation period, or whatever it is, we can describe those data. And we can also predict them. So we can predict that if we don't intervene, for example, maybe right here on our level graph, our target behavior is going to continue to go just like it is in baseline. Say you have a challenging behavior, and you can see in your baseline phase it's increasing. Well, we would predict that if we don't implement an intervention, our challenging behavior is going to continue to increase in the future. So our baseline phase allows us to describe the behavior under natural contingencies in the natural environment and predict that if we don't implement our intervention, our data path is going to continue the way that it's going in baseline. Okay, if you have a lot of variability in your data and you want a way to actually calculate the baseline stability, so you can't actually just look at it and draw a line through it, then this is a good method for you guys. So you can get the mean of the data. So here we have 5 sessions, and here are the data for each of those sessions. And we can add them up and divide by the number of data points. We have 5 here. So when we add these data up, we get 71 divided by 5, and our mean is 14.2. And so we actually just rounded down to 14. But when you get, and then what you want to do is you want to take your mean, and you want to take 50% of that mean. So take your mean, multiply it by 0.5, and that gives you 7. So now we can take our 7 and we can get a range of data points that's acceptable to ensure us that we have stability. So we want to do 14 plus or minus 7. So our range for these data are going to be 7 to 21. So our data points can vary from 7 to 21, and we can still consider that stable. If our data points go outside those ranges, then we would typically say that we have too much variability, and we want to continue to run our baseline phase until our data points fit in to that range of 7 to 21. And we can see in here that all of our data points are in between that 7 to 21. So we would say, and for these data, our baseline are stable, and we would be able to implement our intervention. Okay, let's do that with these data. So we got y-axis are multiplication problems, x-axis are sessions, and let's look at our data points. Here are the data from each of our data points. We have 7 of them, so we're going to add this up and divide by 7, and we get 1. So our mean is 1. Remember, to get our range, we want half of the mean, or 50% of the mean. So we're going to take our 1, multiply it by 0.5, and we get 0.5. So our range is going to be 1 plus or minus 0.5, which takes us from 0.5 to 1.5. And we can draw a little range square within our data, and we can see that our data points are actually a little bit outside of this range. So this is when you have to make a decision as a researcher or a practitioner. Are my data stable enough? Although this is a formula, you still might decide that your data points are stable. And we can see that although our data points are outside a little bit, they're not too far off. And so the researchers for this study decided that it was stable enough to implement treatment, which they did. But that's up to you. You can get your range. You still may decide to run this out a little bit and ensure that all your data points are in that range. Or you may decide that, hey, although it's a little bit outside, it is close enough, so we can go ahead and implement our intervention. And here's the intervention, and here are the data that the experimenters got. And now what we're going to do is we're going to look at the data from our two conditions, our baseline and our intervention conditions, and we're going to compare those two and actually look at, is our intervention effective or not? And to do that, we look at level, trend, and variability. So let's go through each of these. With level, basically you're finding the mean of your data in baseline and your data in intervention and looking at the difference between those two levels. So if we look at these data here and we get the mean, we can see our mean line is about 12 and our mean line in our intervention phase is, it looks like about 7. So we can draw those mean lines, and this kind of takes out the variability, and we can see, is there an actual difference in the level between our baseline phase and our intervention phase? And we can see from here that there is a big jump in level between our baseline and intervention phase. So we would typically conclude, just with regards to level, that this intervention was effective. All right, for these data, we're looking at the appropriate hand raising by a child in class. We can see on the y-axis we have number of responses, on the x-axis we have sessions, and so we want to find our means. So for baseline, our mean is 15.2, so we add all these data points together, divide by the number of data points, and therefore our line would go right here. Our treatment, our mean is 22.8, so add all these data points together, divide by the number, you get 22.8, and therefore that would put our line right here. So we can look at the level and see if there's a big enough jump in the level between our baseline and treatment phase. And we would probably say, yes, we do have a clear difference in level, so our intervention for these data is effective. All right, let's look at this example. So our mean for baseline is 15. Our mean for treatment is 15.1. And we can see that although our level is a little bit above it, it's really not a big enough difference. And therefore, for these data, the intervention was not effective. Okay, in addition to level, you also want to take into account the trend. And this is the direction of the behavior, so the direction of your data path. And when you want to look at the direction during your baseline phase, so before treatment, and after or when treatment is being administered, so your intervention phase. When you guys see the label TX, that means treatment or intervention. And when you're looking at this, there's 3 directions that the behavior can typically take. It can increase, it can decrease, or there can be no change. And so let's look at our data for Kathy. We can see in our baseline phase, our data path, the trend is increasing. And in our intervention phase, the trend is decreasing. So you typically want it to go in a different direction. The direction or the trend in your intervention phase, you want it to go in a different direction than your baseline phase. And this does. So say we have a problem behavior, it's increasing in baseline, we implement a treatment, and now our trend is going to decrease, which is what we want. So we would say that this intervention was effective. Let's look at Roger's data. We got an increase in trend in baseline, and then we would say we have a decrease in trend, so it levels off in the intervention phase. Let's go down here to Nancy. We have a level trend, so it's staying the same in baseline, and we can see that it's increasing in our intervention phase. And then let's look at Peter's data. So with Peter's data, we have an increase in baseline. We implement our intervention, and we still have an increase in our intervention phase. So there actually wasn't a change in our behavior. So for Peter, we would say that the intervention was not effective. And this is where it comes in. We talked about our baselines being predictive. So we would predict, let's go back up here to Kathy, that in baseline, like we said, our trend is increasing. So we would predict that if we don't intervene, it's going to keep increasing. And therefore, if we get that difference in direction, we can show that, yes, there was an effect of our intervention. So let's go back down to Peter. We can see that our trend and baseline is increasing, and we would predict that if we didn't intervene, it would keep increasing. And we do intervene and it's still increasing. So that's why we would say that our intervention was not effective for Peter. Okay, so let's talk about trend lines. So if you see these data, we got number of responses on the y-axis, sessions on the x, and what you're going to do is you're going to draw a line that captures as many data points as possible. So we can see right here, our trend line is increasing. And like I said before, we just talked about, if we did not intervene, we would predict that it would be going the same way. So here's our intervention data. And if we draw a trend line and we get as many points as possible, our trend line is going to be going down. So we can see that the direction of baseline, our trend line is increasing, and our treatment phase, our trend line is decreasing. So we can say that, yes, our intervention had an effect and that our trend is going in a different direction in our treatment phase compared to our baseline phase. Here's some more data. Baseline, let's draw our trend line. And in baseline, it's stable. And in our treatment phase, our intervention phase, it's increasing. So we can say, yes, our treatment was effective. Our trend line went in a different direction from our intervention or treatment phase compared to our baseline phase. Okay, in addition to our trend line, seeing if the trend is increasing or decreasing, we also look at the slope. So the degree of the slope will tell us how strong our trend is. If you have a really pronounced slope, so a really steep slope, then we can tell that the rate of responding is really high. If you have a more level slope, then your rate of responding is lower. And I actually have a cumulative graph on you for you guys. I know we focus on line graphs in this video, but I did want to point out that we really look at slope with regards to a cumulative graph. So remember, with a cumulative graph, your data points are not going to go down. They're only going to go up, or they're going to level if no responding is occurring. So, if you have a really steep slope on a cumulative graph, you know that you have a response rate that's really high. The behavior is occurring a lot. Whereas if you have something stable, then the behavior is not occurring, and that response rate is really low. Okay, let's go back to your line graph. Let's look at our data in our intervention phase. We can see that we go from 20 to 60, and it takes about 10 sessions to do that. So we can see that we kind of have a gradual increasing slope in our intervention phase. And then if we look at our baseline, our return to baseline phase, we go from 60 to 20 in only 5 sessions. So we can see that our slope is decreasing. It's a steeper slope, so a higher response rate in our return to baseline phase. So not only do we look at the direction of the slope, the direction of the trend line, but also the slope and how fast the learner is responding. Okay, let's talk about how to draw trend lines. So as we were talking about trend lines, you guys might have thought, do I just take my pencil and draw a trend line? What if I have lots of variability? What if it's really hard to do that? And yes, these are definitely things to consider. So there are basically 3 techniques that you can use for drawing a trend line. First one you can do is you can just freehand it. When you freehand it, I kind of mentioned this earlier, you want to make sure you get as many data points in there as possible. If you have data that doesn't have a lot of variability, so you can see a really clear line, freehanding might be a really good option. It's really easy. If you can see a really clear trend line, go ahead and just freehand it. If you can't, if you have a lot of variability, then you want to typically do the second or third option. So let's look at these data that we have in this graph. On the y-axis, we got total minutes of exercise, duration per day, and on the x-axis, we have our days. And you can see in baseline, we have a lot of variability. It kind of looks like it's increasing here, but then maybe leveling off or even decreasing down here. So when you have something like this, you want to use more of a technical way of doing your trend line as opposed to your freehand. So the second option, you can do what we call ordinary least squares linear regression equation. I'm not going to go into this. This is very high level statistics. It requires a high knowledge of statistics. It's very complicated. And we typically don't use this method in either the clinical setting or even in research a lot. But it is there if you guys have a stats background and want to learn it. The most common one that gives you a little bit, it requires some statistics, but not high-level statistics, and it gives you an equation to use instead of just freehanding it, is what we call the split middle line of progress. And I have a website for you guys here, but I'm not going to go over it because you guys can look through it on your own, but I am going to demonstrate how to do it with these data. So first thing you're going to do, we're going to focus on this baseline phase, is you're going to take your data points and you're going to divide them in half. So we find our middle, we have an odd number of data points, so we can actually find the middle. And we have 7 data points on the left and 7 data points on the right. So now you're going to find the what they call the mid date. And so this is the middle of your data on the left side and the middle of your data on the right side. And to do this, we are going to get our middle data point. So since we have 7, we have 1 data point that's in the middle. So we can draw a vertical line. And then let's go to the right side, and our middle data point is the 4th one. And so we can draw a line down that data point. Okay, now we're going to find the mid rate. And to find the mid rate, you are going to take all your data points on the left side, and here they all are. And I kind of had to estimate, so hopefully you guys agree with me on where they fall on the graph. But you're going to take these and you're going to put them in order from least to greatest. And then you're going to find the median. So this would be our data point number 17. And so you're going to look over here and you're going to put a horizontal line on 17. And then we're going to do that to the right side. So take all your data points on the right side, put them in order from least to greatest, and find the median, which is going to be 16. So that's our data point here. And then you're going to draw a line that connects the intersection on the left to the intersection on the right. So draw your line, and that gives us our data path. So you guys can look at this website. It talks about what you do when you have an even number of data points or an odd number and things like that. But I think it's a good method for you guys to be aware of and learn how to do, because in the real world, when you guys take data on baseline and your intervention, it is probably going to have variability in it, especially in an applied setting like the school system or in a classroom. You have a lot of factors going on. There's going to be a lot of variability in your data. And so it might be, most likely will be pretty hard to freehand it. So I think this is a really good way to give you guys a method to get that trend line without freehanding it and actually getting a more of an accurate trend line so that you can accurately evaluate your intervention. Okay, last I want to wrap it up with variability. So I've talked about variability as I've gone through this video, but I just wanted to point it out and explain it a little bit better to you guys. Remember, with variability, this is how far your data points are from the mean. So let's look at graph A. We can see that we have a pretty straight line. We can draw a really good level line. We can draw a really good trend line within here. And that's because we don't have a lot of space between our mean and our data points. So this data path does not have a lot of variability. But look at B. We got lots of variability. So lots of distance between our mean and our data points. If you have lots of variability, it's harder to draw those level lines. It's harder to draw those trend lines, and it's harder to analyze your data. So just keep that in mind. If you have a lot of variability in your baseline phase, you need to run out your baseline phase until you have a data path that's more stable. And if you have a lot of variability, it's harder to draw those level and trend lines, and it's harder to actually analyze whether or not your intervention was effective or not. So it's harder to compare data paths that have lots of variability to each other. Look at C. This trend line's going up. It's increasing. You can draw a really clear line in that there's not a lot of variability. But if you have something like this where there's lots of variability, it can be a little bit harder to draw that trend line. And same with your decreasing trend. Lots of variability, harder to draw those trend lines, harder to analyze your data. So that's when you might want to go into that mean range with your level lines, or doing that split middle path with regards to the trend line. All right, whenever you guys analyze your results and you compare data from intervention to the baseline phases, We have two types of criterion. We have experimental criterion and clinical criterion. With experimental criterion, this is going to verify that the change in your dependent variable was actually due to your independent variable. So is your change in your target behavior actually due to your intervention or your treatment? And if it is, then that's great. You've demonstrated a functional relation, and that's really awesome with regards to internal validity. However, in behavior analysis, although we definitely want experimental criterion, we are looking for what we call clinical criterion. And this is the idea that that change in your dependent variable, you want it to be large enough that it actually has an impact on the learner that's receiving your intervention. It's great if the dependent variable changes even a little bit, and you can show that it's due to your intervention. But a little bit of change, you don't know if that's actually going to be large enough to make an impact. And so when you're visually analyzing your data, you want to make sure that there's a large enough difference in your level lines, or there's a real pronounced difference in the direction of your trend lines, because you want your intervention to really have an impact on those who receive the intervention. And if you guys remember our 7 dimensions, this is going to be the affective dimension. So making sure that your procedures improve the target behavior to a practical degree. It's great if they improve the target behavior, but you want it to hit that clinical criterion and actually improve it to where it has a really good effect. It actually impacts that person's life. All right, guys, so we talked about baselines. You want to make sure that you run them out so they're stable. At least 3 to 5 data points need to be stable. We talked about level, so those are those mean lines in your data, and you can compare your level lines from your baseline in your intervention. We talked about trend lines, whether the direction of the data path is increasing, decreasing, or being level, and if there's a change in the direction between your baseline and your intervention. We talked about the slope. So if you have a steeper slope, higher rates of responding, a more level slope, lower rates of responding. And then we talked about how to draw our trend lines. You can freehand it, or you can use some other more advanced methods. And then we talked about variability in our data. So if there's less variability, easier to analyze, you get a more accurate conclusion as to whether your intervention was effective or not. If you have lots of variability, it can be a little bit harder to tell whether your intervention was effective, and it can be harder to draw those level lines and those trend lines. And then finally, we talked about our experimental and clinical criterions. All right, guys, thank you guys so much for listening. If you have any questions as you're going through this, then please email me. All right, thanks, guys.